So many colors showing up on this. I guess we're just moving up like floating worlds, aren't we? Either way, lucky day 13 today. Not a Friday, but still 13. We are on the edge of Lava Island, but there's no lava. We'd be happy about that if this was Minecraft. A lot of ash. The valley between the mountains is full of mirrors, which are aligned. As you move through mirrors, several of them have fallen. Mirrors are extremely flat and shiny. Can't tell when you're going to step on a mirror, which I don't want to step on any glass today. You note down the patterns of ash, dots, and rocks, hashes, that you see as you walk. I guess this is our puzzle input, ash and rocks. Perhaps by carefully analyzing these patterns, you can figure out where the mirrors are. Okay. To find the reflection in each pattern, you need to find a perfect reflection across either a horizontal line between two rows or across a vertical line between two columns. In the first pattern, the reflection is across a vertical line between two columns. So here, I wonder if this is one reflection. In this pattern, the line of reflection is the vertical line between 5 and 6 because the vertical line is not perfectly in the middle of the pattern. Part of the pattern has nowhere to reflect onto and can be ignored. Every other column has a reflected column within the pattern and must match exactly. 2 matches 9, etc. This sounds like we can just flip some slices and do equality. Second pattern reflects across a horizontal line instead. So we fold that in and then we have to find another one and we have to fold it. So it's kind of like an origami pattern. To summarize your pattern notes, add up the number of columns to the left of each vertical line. To that, also add 100 multiplied by the number of rows above each horizontal line of reflection. Also, turn around on Tuesday when it's raining. In the above example, the first pattern's vertical line has 5 columns to its left. Is that including the one that we kind of ignored? 2, 3, 4, 5. It is including the one that we ignore. And the second pattern's horizontal line has 4 above it. 1, 2, 3, 4. Find the reflection line. Yikes. So I guess it's either horizontal or vertical. Immediately off the bat, I think of the only locations that can be starting locations are locations where 2 characters are the same next to each other. So like this could be a starting location or this, but not this. So at least we can cull the search space a little bit. After that, I feel like it's mostly a mechanical matter. This doesn't modify the actual result, does it? Because they're mirrored, so we're never adding additional like hashes. Oh wait, why is this 2 different inputs? Oh, there's only 1 reflection for each. Okay, so this top one has a vertical mirror and this bottom one has a horizontal mirror. Okay, so if it's a horizontal, then 2 lines match, right? So if line A and line B match exactly, then it's a horizontal. Same for vertical. But we have to then also match on everything else. So it's like, it could be a coincidence. I don't see any coincidences here, but probably in our input there will be. So let's get started at least. I'm going to wait to see part 2 to figure out if I actually have to do something mathematical. And we're just going to create day 13. Let's grab the original input. And I feel like really the thing that I care a lot about is trying to do as little work as possible to get this done. Because I feel like part 2 is going to be do this on a huge thing. So to summarize your pattern notes, add up the number of columns to the left and add 100 multiplied by the number of rows above each horizontal line. Okay, so this is going to be 405. I feel like we can pull this into its own test. So let's get a test for the horizontal and a test for the vertical. I guess those can be RS test though. Let's see. I think they have to be a different test because I don't think I'm going to test so I think they can be an RS test here. And I'll stop this on each of them, pull this input out, and we'll write our cases. So that's the input. And then we have some number. I think one of them is 4. So I'm going to type 4. And then this is going to be test for horizontal. And then this will be case input, case expected. And this will be expected toString, and I don't know that this is going to be process. Let's call this something else. Let's call, I guess, detect fold. We have to bring in RS test. Input needs to be a string slice, and expected needs to be, I don't know, we'll call it a usize. It doesn't really matter. So detect fold then. I guess we could do an enum here. So we do fold vertical and fold horizontal. So this pattern, the second pattern has 4 rows above it, and the first pattern has 5 columns, if I remember correctly. Yeah, 4 times 100 plus 5. So this one's 5, that one's 4. That means we need this enum to be defined. So let's define that. These will be use sizes, and we'll derive debug on them. So at least we have a potential function here, detect fold, which will return horizontal or vertical. And then we need this function, right? We need detect fold on a string slice, returning a fold. Oh, we don't have equality here, so testing is going to be weird. So let's do eq and partial eq, because if they're exactly the same, because they're use sizes, then it'll be fine. I think I'm going to run these tests individually. So if we try to run the part ones, it'll fail for the moment. And our type error, expected use size found fold. So expected is fold, that's correct. Let's not toString this because detect fold will return one or the other. And now at least we have the opportunity to pass folds. And because I think writing the horizontal detection will be easier, and it will give us a basis to write the vertical. So we really want this. We don't want case 1. We actually want case 2 to start with. So 1 failing, case 2, that's our horizontal. So let's take this input. Let's do what? We need to find 2 lines that are next to each other to start with that are the same. From those, we can expand out. So we could do something pretty silly here, right? Like input dot lines, enumerate to find the indices, windows. I want tuple windows because I want this to have defined size. So this is from itertools. We don't need the 2 there if we're doing tuple windows. Input lines, enumerate, tuple windows, filter, line A, line B, line A equals line B. These are going to be with the indices. So we're going to start with getting this to be just a vec, and we're going to debug out. So a vec of string slice. I guess it's a vec of use size string slice because we're filtering. Tuple windows needs to come in from itertools, so we need to bring the itertools trait in. So we use the Rust Analyzer quick fix to bring that in. Is there an issue with our iterator items? Is use size string slice? Yes. So it's both of them. It's not one. So it's 2 of these. So copy that, wrap it in a tuple, and then we get both of them. So we have the first line and the second line indices. That's going to be pretty important. And then let's just debug result for now because we don't have too many logs, so we don't really need tracing yet. So we've got these 2 lines. That works for the small input. I have a feeling that when we run this on our actual input, we're going to get more of them. So maybe we create an additional binary just to run it on our actual input that runs detect fold. And then we can actually evaluate our, we don't need all of this scaffolding here, but I'm going to probably use it. Part 1, debug, horizontal fold.rs. Long name, don't really care. We haven't done much here. Let's do part 1, not process. But let's get that let's get that detect fold function in here. We don't really need heap profiling, so I'm going to remove all of that. I will leave tracing subscriber in here. So we pull in our file, we process, and then we're printing the result. So I guess we need to write our parser for splitting this out first, right? We need to get all of the items if we're going to write this binary, that is. So we've got this detect fold function, right? And what does our input look like? It's a bunch of these, right? So we need to figure out how many there are. Well, we don't need to figure out how many there are, but we need to figure out how many horizontal matches there are in each of them. If there's 1 horizontal match in each of them, then we're pretty good. I'm just curious about that number. So let's just hack this together for a second. These are separated by 2 new lines. 1, 2, yep. So debug, let's see. We'll just do 2 new lines here. Guess we're already iterating over that. So for a line in file split, not for a line, but for, we can't use the word box. For, what are we calling these? I guess we'll call them mirrors. Then we're going to bring this in. We won't actually get a result here because we're to-doing. So these will fail, like they'll panic. So we detect fold here. We assume there's always a fold, so there's nothing to like handle. And then we'll change this to debug. So if we run cargo p day 13, it'll tell us, hey, there's a bunch of them that we could do. And then we just get to copy this. Or if you have autocomplete, like I do, unfortunately, I named them all the same thing. But if we go and we tab through, we get part 1, debug, horizontal fold. We run that, that will crash basically. It's saying fold is private. That is totally fine with us. We can expose fold here if we're going to use it. And then we run again and we see result and then we panic. So this looks like it has 2 matches in the first one. Was that 1 and 2? Yeah, 1 and 2 match, and then 10 and 11. 10 and 11 do match. So these need to fill out the shortest. So my guess is it's this one up here. So it's a horizontal here. And we do have to account for the fact that there could be multiple. So just a little debug there. Get rid of the clippy errors there. Back in part 1, we've got detect fold. So we've got options here, basically. If we take our options and we iterate over them, then we can look at the original input. So we're probably filtering again here. I'm just gonna let it do 2 filters because that feels okay to me for the moment. Probably can merge this into 1 filter later. So we have options 1 and 2 and 10 and 11. The options here are take the indices, right? Index A, index B. We have to do, I guess because of the order, right? We can do 0, 0, or 0 dot dot index A. And then we're gonna need to reverse this so that we can go from the inside out. And we don't need to include index A because we've already checked it, but we will need to remember that we're not including index A if we're checking the length later. So we'll call it lines A equals this iterator. We're gonna to do this so we can get rid of a couple of these. 0 dot dot index A. Index A is a U size. We need to do that to the actual number. And then lines B, we also need to go from where we are to the end, but we can do that from index B dot dot, right? So we can do an infinite range here. And I think zip will end at the right spot for us. If we look at zip in standard iter, converts the arguments to iterators and zips them. Perfect. That's great for us. See the documentation for more. Zips up. I believe it will stop at the shorter one. If the zipped iterator has no more elements to return, then yada, yada, yada. We can pass anything. We can pass our ranges. It's great. How does it handle 2 different lengths? Zip is often used to zip an infinite iterator to a finite one. This works because the finite iterator will eventually return none, ending the zipper. Zipping with 0 dot dot can look a lot like enumerate. Yes, that's absolutely true. So if we've got 1, 2, 3, and 2, 3, 4, and we zip and we skip 1, then we get 2 items and then none. If we have foo.cars.enumerate or zipper 0 dot dot and foo, doesn't show us what it does at the end, which is really what I'm curious about. So we're going to click run in that doc. I'm going to run this. We're going to drop this on the vertical so that we can read it. And then this collected. So what is zipper.length? It has to be finite. So I'm assuming it just is none after that. 3, this is our iterator for I in this, debug I, just making sure that this behaves the way that I want it to before I actually go use it. This should stop at the shorter iterator, which is foo, which is great. That's exactly what we want. We want to zip. So we've got lines A and lines B. We've got infinite iterator for lines B, and we've got finite iterator for lines A. So at least it will stop at lines A, but this could actually be shorter. So I think, can we do negative slices is a question that I have. Let's do another check here. I think we can just reverse it. Okay, so let's do that. Let's do lines with a slice, and we need to reverse that. So we need to iterate over it. What is our issue here? It doesn't matter what we run. Not found in the scope. Is it input? It's input. And I guess that needs to be into iter is my guess. Method not found on str. So what we really need is parentheses around our slice. And what we actually need here is the collected lines of stir. So let's get that first. Let's call it lines equals input.lines.collect. And I'm just making this concrete type to make it easy. We can always go back and make this a iterator or something else. So what's the issue here? This is still using input. So we need to use lines with the indices. And then let's go back to running our test for case 2. So we've got lines A, which is going to be this slice of lines. And then same thing for the other, except our range is going to be infinite in the direction of B. Infinite for a slice actually means that it will go to the end of the slice. Is there something wrong? Cannot infer type of lines.iter. Slice indices are of type usize or ranges of usize. Is this a reference? Yes, that's our issue. So we've got lines A and lines B. If we zip lines A and lines B, then I think we can just call all and we check to see if A equals B. And if they all equal, then we get a bool here. So this is true. And is that just our return type? I think that's our return type. I don't know that that's actually our return type that we want though, because if we do this and we need to get the number of rows to the other side, I guess, right? So of the midpoint, we need whichever of these ranges is bigger, right? So this dot then sum, and then I think I'm just gonna reconstruct these. So 0 dot dot, or I guess index A is that, right? So this is how many are above, and then we dot max it with lines dot length minus index B. Is that the right number? Type usize cannot be dereferenced. Why is this a usize now? What did I change? Oh, I changed it to filter map. Of course I did. Okay. Always good to be aware that the functions you use sometimes take references, sometimes they don't. So lines A, then sum, and then this collects into just that length, right? I assume in part 2 we're going to have to fold these multiple times, but it doesn't matter at the moment. So result, detect fold. This is detecting a horizontal fold right now, and we just need to mirror this logic for columns. So we can actually reuse, what was it, day 11, I think? We did columns, so we'll be able to reuse that logic. But we filter map these and we get indices, or I guess lengths, right? So I guess this is find map, because we're intending to only find one. So find map will result in an option, and the option will be that option usize, so we don't even need to type it, and then we debug, right? So the answer there then is when we run detect fold on our debug binary, what do we get? We get none. That's not good. I guess we don't need line A and line B in this comparison. We'd only need the indices here. So lines A and lines B. Let's debug lines A and lines B. Let's start off with these. I guess these are iterators, so they're going to be annoying to debug. So instead, I guess we can inspect here. We do AB and we debug AB. They'll come on different lines. We run this and we get these two and those two. And that doesn't make a lot of sense, I feel like. 41, none. This is about the time that I feel like tracing is going to start being useful. So maybe we'll switch over in a second. So index A, 1, index B, 2, right? So we should end up with 0, 1, which will just be 0. And I guess index B is included. So it really needs to be either both of them or neither of them. And then we get 13. So we get the longer of the two, because the first one is the right one, I think, if we look at the input correctly, right? Because this is the right fold. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's correct, I think. So our test then should pass. Let's get rid of the debug there. Let's get rid of the debug here. Let's return, I don't know, fold, horizontal, and then result. Is that what we need to return here? And then expect should be a valid fold. Interesting that there is a match in our second one. Is that supposed to happen? I guess technically, right? Because this match is here. Why are we getting two values? Detect fold test, and I'm doing case 1. Oh no, sorry, I ran the thing. It is still concerning that we get 2 of them, I think, but well, actually, no, it's not, because they could both be horizontal. We need to watch our test here. 1 test run, 0 passed. That's fine. Horizontal 4, horizontal 3. We're expecting 4 and we got 3. Is that what happened there? So maybe we took our debugs out too early. Let's get this inspect back in here. Good. So at least 3, right? So this is, I think because we've included the base, this is valid. So 1, 2, 3, 1, 2, 3, 4. And we're getting 3 instead of 4. We should be getting 4 from this. So is this calculation wrong then? Let's do debug here. That is getting 3. Why is it getting 3? Lines.length minus index.b. Oh, because I'm just doing one calculation. Why am I doing one calculation? Index A. Let's start with this. Let's do good old debug here and good old debug here and see what numbers we're getting. We're getting 3 and 3. Index A is 3, so it needs to be what? Index A plus 1? That feels weird. Forcing that feels weird. Why do I have to force that? Because we're doing inclusive range here. So 0, 1, 2, 3 would be 4. Yeah, that makes sense. So that's not too bad. We'll leave that there. That seems right, logic-wise. So we're getting our test to pass for horizontal. We also need to do vertical. Vertical is going to be a little bit more annoying, but I think we can do the same thing. In part 1 of day 11, we do a similar thing here to get the columns. And I think if we do it this way, then we can collect those columns I don't know that it's going to be the most efficient way, but I think it'll work. So this is effectively detect horizontal fold, right? And then I think the only difference is going to be what we passed in originally. Let's write detect fold here though, and we'll write it in the same way. And I'll paste this in here. This all, the logic needs to change here. This is the logic from day 11, but it's the same idea, right? Empty columns isn't what we want. I think we can just treat this as an iterator. So columns is going to be input.lines. We're going to map over those for the characters. Do we need to collect here? I would love to not collect here. I don't think we do. Looks like we are good there with just a mutable declaration. Ooh, that is running our benchmarks. We don't want to be running our benchmarks right now. I'm going to have to kill that. It spawned off into its own. Why are we running our benchmarks here? Is that actually what's happening? It should be just the tests, right? Yeah, one test. Oh, but this is probably going infinitely. That's fine. I mean, that's not fine, but you know, whatever. Break this for the moment. I am going to need to kill this process, unfortunately. Poor process. Okay, so we've got columns. I made it an iterator. Is there any reason that we can't do it the way we're doing it? I think we do actually need that collect for the moment. Can always go back and change it. I'm going to keep this collect because the goal here is to repeatedly iterate over all of the items of this columns. And if we keep it as an iterator, we can only iterate over it once. So I think we do want a vec here, which is fine. And then we are going to use the same logic here. We haven't collected into our columns here. I wonder if we want to. So from function, this generates our column iterator effectively. So let's make it easy on ourselves for the moment and collect that. And this is going to be slightly different, right? This is going to be a collect into a vec of car. If I am thinking about this correctly, let's call this columns. Yeah, vec of car. We could collect this into strings. I think we would want to do that if we were doing it like this, but I think that the comparison for slices would also work here. So I think we're good. So if this is detect fold and we have, I guess I can rename this columns. Let's rename this one columns iter collection or something like that so that these are different. So columns here is then our vec of cars, which this vec of cars represents each column, and it would otherwise be our vec of string slices here. So we have lines effectively. This is lines. So then we take this logic that we just had and we stuff it here, and it doesn't work for exactly what we have right now because we don't want input.lines, right? Because we already have these. So we want just columns.iter, and then we'll enumerate. So that'll give us the number of the column, tuple windows. These line A and line B are going to be vec of cars now, which means that when we do the comparison for lines here, this is going to be columns, and this is going to be columns. And does it all just work out in that case? That would honestly be wonderful. So let's run case one and see if we get the result that we want. One test passed, case one passed, I think. So I think we're good. I think we have horizontal and I think we have vertical. Both of these need to kind of be done on everything if they fail. So let's do the silly thing here, and both of these will return a result. We don't really care about this error, so I'm just going to make it a unit for the moment. I guess if I'm going to make that a unit, it really should be an option. So option fold, and this is sum. If this result is an option, right, then we should do result out here dot map num fold vertical with num inside of it, which should give us back our option. And then we'll do the same here. This will be an option. And we can merge the logic here if we want to later. Result.map num fold horizontal num. Okay, so both of those should work. And then our test needs to update because these are options now, but it needs to unwrap. And this is going to be detect fold, but this one is going to be detect vertical fold. And we don't have a detect fold anymore. So fn detect fold, given an input that's a string slice, we're going to return an option fold. We have to return one, honestly, but we are going to do detect vertical fold input or detect did I call it horiz or horizontal fold input? So detect vertical or detect horizontal, and detect fold is going to be our thing there. I think our binary is going to fail on that result, but now we have detect fold. And if we go back and we run our tests, both of our tests should pass. So let's get all of the tests running. Do we want all of the tests running? Let's get all the cases running. Let's make sure the cases work. 2 tests, case 1 and case 2, both look like they're passing. So that's great. Then what do we do with that information? Okay, so the math here is add up the number of columns to the left of each vertical line of reflection. To that, also add 100 multiplied by the number of rows above each horizontal line of reflection. In the above example, the first pattern's vertical line has 5 columns to the left, and the second pattern's horizontal has 4 rows above it. Oh, it's always above. Okay, that's good to know. Always to the left and always above. So let's change our logic here because it's not the max. It is always to the left, which is index A, and then always above, which is also index A. Is that right? I think it is. So it's always index A. These should still be running. Both pass. Wonderful. So let's run this on everything, I guess. Let's take that debug input here that we used, copy that into process, and then we have input.split here for mirrors and input.split detect. I guess not for mirrors. We're going to want to do input.split .map mirror, and this is going to be detect fold collect. We'll get rid of this other stuff, and this will be let result equals this. This will be a vec of folds, and we will, I guess, to do this and debug result. Your system has run out of application memory. That's not good. What am I doing? Cargo's not running. Photoshop is using 7 gigs. Let's quit Photoshop. Free up 7 gigs of free memory. Why did we run out of application memory? Okay, well, hopefully that doesn't affect the recording. Because I did have an errant process. So let's do not cargo watch, but cargo next test run. And that gives us, oh, right, we can't run part 2 yet. So let's run part 1. And input.split.map detect fold value of type fold cannot be built from option of fold flat map to the rescue. So we run, we get the results, we get 5 and 4. Let's get rid of some of these other debugs so that they're not really in our way, but they don't really go anywhere either. So we get 5 and 4. Those are the right numbers. So what do we need to do? We need to add up all the verticals and multiply by all of the horizontals. Add up the number of columns to the left and then 100 times the horizontals. I misnamed these. No, I didn't. I'm good. Okay, so here we need to continue iterating, I guess. Let's do a fold 0, 0, and we do, what is our match item? Question is, why is fold complaining? Argument of type vec part 1 fold is missing. Method takes 2 arguments, but 1 argument was supplied. Is that because this is technically, yeah, okay. I put the closure in the wrong spot. Remove that, fill the match arms here, horizontal num, vertical num. Think that these have to be use size just because I can't see them being anything else. And then horizontal is 100 times num, and it is, let's put that in, I guess, 0, and we plus equals with that. And at the end here, we return the accumulator. Oh, it wrapped in when I saved. Oops. I guess we can return the accumulator from each branch. It doesn't really bother me. So we do accumulator.1 plus equals num and return the accumulator. And then the accumulator is not supposed to be a vec folds. It's supposed to be that tuple. Why is it a vec of fold? Run this test. Expected vec of fold found use size. Is that because, oh, I typed it up here. That's the trouble with typing everything. This is now a tuple, but it doesn't matter. So we get, oh, right, because this needs to be mute because we're going to mutate it. And then if it's mutable, we don't need to do anything about it. So then we get 405. So this is going to be okay. And we're going to call this horizontal and vertical. Those are the right ones, right? Let's do horizontal plus vertical. Save ourselves a little bit of typing, hit toString, save that, run it on our tests. 3 of our tests are passing. The one that skipped is part 2. Let us run. I have a hankering that we should run this in release mode. Well, that ran significantly faster than I thought it was going to. Let's hope that this works. Yeah, okay, so that works for us. Sweet. You resume walking and smack run directly into one. Hopefully nobody was watching because that must have been pretty embarrassing. Upon closer inspection, you discover that every mirror has exactly one smudge. Exactly one dot or hash should be the opposite type. In each pattern, you'll need to locate and fix the smudge that causes a different reflection line to be valid. The old reflection line won't necessarily continue being valid after the smudge is fixed. Here's the example again. The smudge is in the top left corner. If the top left hash were instead dot, it would have a different horizontal line of reflection. With the smudge in the top left corner repaired, a new horizontal line of reflection between rows 3 and 4 now exists. Row 7 has no corresponding reflected row and can be ignored, but every other row matches exactly. In the second pattern, the smudge can be fixed by changing the 5th symbol on row 2 from dot to hash. So it can change in the mirror and it can change outside. So after the change, it looks like it can be either a horizontal or a vertical. Now the pattern has a different summarize your notes, but instead use the new different reflection lines. In this example, the first pattern's new horizontal line has 3 rows above it. Okay. I don't know how we're going to do detection here besides changing every individual dot and testing each of them, you know, n by n times, which is presumably not the right answer. Is there any pattern here that we can abuse, right? Like this vertically slices, and the one it wants us to change is this one, which isn't in this vertical slice, but makes the horizontal valid. So the horizontals have to come before the verticals, maybe? Everything else looks like it matches except for this last line. And I think a fold will always be invalid on that last line because they're all odd from what I can tell. 1, 2, 3, 4, 5, 6, 7, right? So this one was a horizontal, right, on this. And what was the 5th symbol on row 2 from dot to hash? And then that changes it to be the horizontal, the new horizontal. 0, 1, 2, 3, 4. They mean this? 1, 2, 3, 4, 5. This one? 1, 2, 3, 4, 5. This one? Yeah, that one. How do we tell though? So maybe our number of tests just go up. So in where's lines? Where's our filter? Our filter here, right? We're looking for line A equals line B. And maybe we should be looking for line A and line B are equal or one off. If they're one off, then we continue as usual. It feels like we have to keep around that detection though, because we basically need to detect which mirrors are off by 1, and then those are valid. I'm assuming there's only one that's off by 1, because if there are multiple that are off by 1, then we're going to have problems, because then the result is non-deterministic, I guess. You got to pick one. So when we filter here, we at least have to change our logic. If line A equals line B, or how do we do that? Can we do something tricky? Probably not. So line A equals line B, or line A dot hitter. These are cars here. This is the vertical one. These are columns. Yeah. So we're doing columns first, I guess. So line A dot iter. So that's a vec of cars already. Well, can we just dot zip? Can we line A dot zip line B? And then we map that into A and B, where A equals B. Maybe we filter map. Let's filter map A equals B. Let's filter map for A not equals B, maybe? A equals B. Trying to figure out how to do this count. If we filter map for A equals B, then we will get count minus either count full length or count minus 1. If we filter map for A not equals B, then we need to have at most 1, if not 0. I guess we filter because it doesn't matter. We're doing just a regular test. Dot count is less than or equal to 1. So this is our new, and then we can iter here, I think, if that's the issue. That is the issue. Cool. That is a really weird looking line, but I'm going to leave it. So then we should be iterating over this vertical slice here, right? And I think in this case, we're looking for one that is one off no matter what. So I don't actually think we want line A equals line B, but we do want this just 1 for the entire. So eek. So we're filtering down to all the possibilities here, but I think we need to do the same thing. I feel like there's an easier way to do this overall, but basically if we find a vertical slice that is only 1 off, right? So all of them have to be A equals B or this, right? And in that case, we do need the counts because the count needs to be exactly 1 that is different. Is there an easier way to do this though? If we concatenate both iterators into a string and then compare them and make sure that they are 1 different, that should do it. So instead of doing the check we're doing right now, maybe if we do lines A dot iter, I guess lines A is what? Iterator where the item is a vec of cars. So this is going to be mildly mildly annoying. So if this works, I'll come back and rewrite it, I think. But lines iter collect. I'm collecting the lines in reverse order. I guess these can be flat map then, or flatten, because we need the entire list of cars. So V is a car now. And we need a filter here where I'm doing this in part 1, aren't I? All right, I'm going to copy this whole thing into part 2. Whoops. Save that and then try to revert part 1 back to its working state. Okay, that should be part one's working state. Let's close part one file because we don't want to do that again. And then get back to, okay, so lines A.flatten, zip with lines B.flatten means we have car. We need to filter for A not equal B, count equals 1, in which case that is a valid. Should probably rewrite that as an if expression. But I think that's what we need to do. So we need to do this little doohickey to filter this first line out. Or we can do this one again for those two lines and make sure that they are at least one different. But I'm going to leave in the equality there, I think. So this is the same thing, but this is going to be string slices. So these need to be cars if I'm going to keep that logic. And then these both need to be cars to do the second test. Well, those don't necessarily need to be cars. They do need to be flattened. And we're going to take it up here and do cars, I think, right? Each of these gets mapped over for cars, maybe. And then we get the flatten here, and the flatten works. So we get the car, the car. And then we filter and count in the same way instead of all, wrap it in our paren. And then we're getting a fold that has exactly one character missing, which hopefully is enough to determine. And I think what I saw earlier is that this needs to get flipped because the way they set up the practice problem is we need to do horizontal and then vertical. So if we do that, then this all comes to 400. And these, I don't know what these would be. Do we keep those tests? First pattern's new horizontal line has 3. Second pattern's new horizontal line has 1. So this is now horizontal and it's 3. And the other one is 1. And if we run these tests, oh my, they pass. Oh, do we dare run this? Oh, it ran. It ran and it gave us an answer. And it's the right answer. Oh, I've never been so happy about getting the answer. Okay. All right. Okay. This is not the, cleanest code, is I guess what I'll say. Let's run our benchmarks at least, just so we know what we're dealing with. Bench for day 13, and we are running in 212 and 244 microseconds. So not too bad, not too bad. Let's see what we're dating. Part 1, 13, about 330,000 bytes. 330 kilobytes, about 3 kilobytes alive at max heap size. I assume that part two looks almost exactly the same, which is really interesting. 329,800, 329,800, 3456, 3456, 188. That is the exact same, actually, which is, in my mind, really interesting. I know that we aren't doing too much different, but we're creating additional iterators. We're doing different logic here. We're not doing any, we're doing filter, but we are counting. So it's just interesting to see the exact same result. I guess we are dealing with cars here, which are not heap allocated types or anything. So we wouldn't necessarily see that show up in a DAT profile. I would bet that there's a way to unify this code. At the very least, there's a way to unify the vertical fold and the horizontal fold, because those are basically the same, except for the fact that we set them up differently in terms of how we construct the original input. Because I think this and that are pretty much exactly the same. Cool. Let's hop into the deep dive here. So the problem for part 1 is there is one fold in each of these inputs that we need to find. So we need to find where it's either a vertical fold or a horizontal fold. The algorithm we're using is basically if we find two lines that are next to each other in the same, whether that is a column here and a column here, or a row here and a row here, those are valid starting points. Everything else we ignore. Once we find valid starting points, I guess we can do an optimization where if they're the only one, we stop there because it has to be there, but we aren't doing that optimization. I don't even know if that would save us much. But then we take each of the lines going outward as a slice. So these two, and then these two, and then those two. And if they're all the same moving out, then they are the fold, at which point we calculate the offset. So the way we are doing that is with two different fold functions and one fold function that sort of combines them together. So our process then is just splitting this input, which again looks like this. So there's two new lines separating all the inputs. We flat map over detect fold. Again, detect fold returns an option. So we want to unwrap those options because for the advent of code input, at least, we will always get one. So we could also expect here or unwrap here. But detect fold for us takes that input. So one of the boxes, one of the sets of mirrors. In the input, it would be like just this or just this. It then chooses to detect a vertical fold with priority or a horizontal fold. .or here is interesting. It is an option, or is it's not an option, it's a function on option, which basically allows you to say, return the first value, otherwise return the second value. Now, there's also or else, which calls a function and is probably lazier. So we could try to see if that has any impact later. But right now we're just running detect vertical fold, detect horizontal fold. If detect vertical fold finds one, it'll return some and that value will get returned. Or we execute detect horizontal fold and that one wins. So after we detect whether it's a horizontal or a vertical fold, then we use the fold function, which is a different thing. Maybe I should have called this crease or something. We start off with, because we might have a whole bunch of mirrors here. So 1, 2, 23, 17, I don't know. I didn't count them. There's a lot of them. So we start off with a tuple of 0. We call them U sizes because I felt like it. Then we take the accumulator as a mutable and the next item. The next item is always going to be one of these folds that we detected. So if we look at the types here, the item is a fold and the accumulator is that tuple that we set up. So we match on the item. If it's a horizontal fold, we take the number, we multiply it by 100 and we store it in the first slot. If it's a vertical fold, we just add that number to the second slot, and altogether that returns us the final horizontal vertical amounts that we need to add together for our final result. Now, all of the interesting logic is in detect horizontal fold and detect vertical fold. So detect horizontal fold and detect vertical fold are basically the same logic, slightly specialized for the string slice and or vec of cars case. So what we end up with here is the input separated into lines, which we've collected into a vec. We do that because I want to take slices of it, and I want to take slices of the rows, not slices of the string slice. So we take another iterator over the lines, we enumerate for each row so we know which row we're in by index. We use itertools tuple windows, which gives us 2 elements. I used tuple windows here instead of the native windows because the native windows gives us a slice of indeterminate size effectively, whereas I really value having just 2 tuple elements definitively. There are 2 options for that in Rust. There's array windows, and I can't remember the other one off the top of my head, but there's 2 of them. They're both nightly. They can't really be used in stable Rust yet. So if you want to go use them, definitely go use nightly. But we filter on that tuple. If the lines are equal, right? If the lines that are next to each other here in our input are equal, then it's a valid starting position. And then we run a find map to find which one of those is the valid starting position. We do that by iterating over the lines using this slice syntax. So what we end up with here is a reversed from the first matching line to the start iterator, and then an iterator of the lines from the second matching line to the end. We can take those and we can zip them together, which if we look at the types here, gives us a tuple of string slices. Then we can check if all of those match because they're in the right order because we reversed up here. And if they are, we return the index +1 because the index is the offset, but it's 0 based, not 1 based. So we need to add 1. And then we call that a horizontal fold so we can know what to do with it later, basically. We could also just have multiplied this by 100 here and then added everything up. But our vertical fold detection is basically the exact same. The only big difference is we have to reorient everything to be columns before we start because there is no like columns function. I do explain this in day 11. So if you're interested in that, you can go check that for more. We use from function and we basically iterate over iterators of each line, which are iterating by cars. And we move all of those forward at the same time, which packs them all into this vec and then produces a vec of cars for each column. So we end up with a vec of cars instead of a vec of string slices like we have in horizontal. Logic otherwise, basically exactly the same. We do the string slices, we do the reverse, we do the detection, all of the equality happens, and then we're good. So that's part 1. And then for part 2, the big change is the detection that we need to do. So I chose to just add an expression here in our filter that says basically if they are equal, just move forward. If they're not equal and they are at least only 1 different, so if they're only 1 different or they're 0 different from each other, then continue. because those are the only valid starting locations. If they're 2 different from each other or 3 different from each other, we can only have 1 difference in our entire fold set. So those wouldn't work as starting positions. Then we do the find map again, and we replace the logic for testing if all of them are equal with testing what number of them are not equal. This luckily works. I don't know for truly generic input, like just arbitrary input, if this would work for all inputs. It works for advent of code because the input for advent of code tends to be very specially crafted, but we are relying on the fact that not only is there only 1 tile that needs to be replaced, but there's only 1 option that has 1 tile that needs to be replaced. So it's conceivable that you could construct an input that had 2 examples of 1 tile that needed to be replaced. And then which fold would you actually choose? So that's it for today. I hope you enjoyed the video, and I will catch you in the next one. As always, if you have any questions, leave them in the comments. Have a great rest of your day.